Okay, a little bit tired, but I want to do a couple of questions today. Let's have a look. Okay, so let's see. We could change this to x plus 2, x minus 1 over um, x minus 4, x plus 1. So, okay. Asymptote. Um, at 4, there's an asymptote. At minus 1, there's an asymptote. At 0, we pass through a half. So let's think about this logically. When x tends to infinity, we were kind of moving towards a 45-degree asymptote. It's not a horizontal or vertical one. Is that right? No, that's wrong. Sorry. When x tends to infinity, we are moving towards the asymptote of 1. And to minus infinity. So, and we have roots at minus 2 and at 1. Okay. So there's a root here, asymptote here. So it's gonna be like this shape. Okay, crosses here and here. Must be coming from up here. So are we talking about something like that? And then I'm guessing like this then. I'm going to graph this in the software just to see how it looks. Let's see. I could have drawn that a bit better. But that's loading. Let's have a look at the next one. So that's y is a half. We calculate the derivative. So that's a half x squared minus 5x plus 4 power minus a half times 2x minus 5. So that will equal 0 at x equals 5 over 2. Okay. When x tends to infinity, this will tend to a sort of 45-degree line. Let's see about just simplifying this if I can. X minus 4, x minus 1 root. So a root at 1 and 4. At 0, it'll be at 2. But we can't have it go. Oh, the software's not working. We can't have it go negative. So if I complete the square, that's root x minus 5 over 2 squared. Minus 9 over 4. So yeah, it could be negative. So we'll have to keep this positive though. 1, 4 has to be less than 1. Because if it's less than 1, like if it's 0, for example, it'll be positive and has to be more than 4. So it's not defined here. So I'm kind of guessing it'll be sort of like this. And it'll be asymptote here. Maybe something like this. Let's try and graph these to see if we're right. Oh, I don't think my software is loading. It's trying to load. No. Let me pause for a second. I'm using Wolfram Alpha. So it looks like it matches up. Yep. Okay, and let's try the other one now. Yeah.